Hello, and welcome to the O3DE Engine YouTube channel. I'm Alex Damarjian, a technical trainer with the AWS Game Tech team. In this video, Principal Solutions Architect Royal O'Brien will provide a developer's overview of O3DE, its setup process, as well as provide some important background information on the Git workflow. Now, before we begin, I want to address an important point about the open source nature of O3DE. And that is, the O3DE Engine community is constantly updating the engine with new features, so check the description below for any updates or videos. Thanks for watching and enjoy the video.
Hi there, my name is Royal O'Brien, and welcome to the O3DE Engine. The O3DE Engine is a fully featured, high-quality, real-time 3D engine designed for building games and simulation, available for any industry, and it's all done underneath of a permissive Apache 2.0 license and open source for the world to use. Today we're going to go ahead and get started to show you how to get things set up with O3DE. So you'll find the O3DE repository is located on GitHub under O3DE, which is where you can go here that we're showing inside the site itself. Now, to start, let's go ahead over to the documentation page, which is docs.o3de.org. Once you go here, you'll be able to learn a lot more about the engine, how you can get started, and things of that nature. But what we're going to do today is we're going to show you how to pull down the source code from GitHub and then go ahead and build it and get your first project up and going. So in the first part of this series, we're going to go straight to the documentation. And from the documentation, you'll want to go into the welcome or release notes, read more. You'll see in here we have a place called setup. Now you can learn everything you need to know about O3DE Engine, but since we're going to learn how to actually pull the code down, we're going to go straight to setup. There are going to be some system requirements that you'll need. You'll find them here, which has the hardware and software prerequisites. To build O3DE, you're going to need to have Visual Studio 2019, the Visual C Runtime, and CMake 3.20 or later. Now, there are some other pieces that you can use that are optional elements that you'll want, such as the WWise Launcher or the SDK, but we'll go into those later. Let's go ahead and get started on what we're doing here. So to begin, we're going to go to setting up O3DE from GitHub. So one of the pieces you'll have is you'll need to make sure you'll have a Git client already installed, and you want to make sure that you've got some open space on the drive to do that. So one of the first things we need to do is we need to actually configure this so that we know to pull down some of the larger files. It uses LFS, so we're going to use git LFS install to make sure that we have LFS initialized. Now, if you have your credential manager already set up for Git, this will be something that you won't have to worry about. When you installed Git, you'll want to have made sure that you use some of the defaults. If you're using Windows, you have the Windows Credential Manager that's actually built in. That will store it in your Windows store and take care of the rest. Now, when you start to clone it, one of the things you're going to need to do first is you need to fork it. When you're working off of the O3DE source, we tend to keep it very pristine and clean. And so when you want to be able to work out of it or be able to create features and things like that, you're going to want to make a fork of it. And so if you plan on just using it, you can clone it straight off of the main repository. But when you need to create features, you'll need to fork it. So in this case, I'm going to go ahead and fork it so that we have one. So we'll go ahead and click on fork. And it says where we're going to fork it. We're going to put it into our own repository. And so this will go through and create the fork for it. And this is where we're actually going to do most of our work. So here we are. We have our O3DE user, O3DE, where we have a fork of this that's actually ready to go. And this is where we're going to pull from. So once we have our fork, we can go ahead and copy our repo. We can do git, make sure that we have our LFS initialized. And then we can get clone from there. Now, again, this is going to pop up a request for either signing with your browser or a personal access token. What you're going to want to do is you're going to build that personal access token. And the reason is because we use both LFS for the binary side as well as GitHub for pulling the code. So what you'll do is you'll go into your account here. You'll go into settings. And then under here, developer settings. And you'll see that at the bottom here, there's a personal access tokens. So you're going to want to generate a new token. And we can call it O3DE token, which is fine. And you're going to want to click on repo and then read org. Once you've got those two, you'll want to generate this token. You want to keep this private. When I'm done this video, this one will be deleted as well. But you'll copy this. This will become your password for what your first request here is, as well as when you get a credential box, it will pop up later and ask you for downloading the LFS assets. So we'll go ahead and paste this, we'll sign in, and this will begin cloning it in. So this is copying from your repository fork that you have, pulling it into the local system, and downloading that. So once it does that, you'll see updating files will count all the way up to 100%. Be aware that there may be kind of a hidden dialog that can pop up. You may not see it or not, but especially if you're on Windows, it'll do that. It's hiding behind there. The username, you're going to use your user account itself, so O3DE test, or excuse me, O3DE user. And we're going to paste that personal access token. And when we paste that in, that will allow us to access the LFS assets. So now that it's actually pulling them down, it's bringing those binaries in, and it'll take a little while to do this. There are several gigs worth of binary assets, graphics, mesh models, things like that. There are other repositories. If you go into the O3DE repo, you'll find out that there are different tests and samples, and you can learn a lot more about it by actually going into that repo, into community, and things of that nature. If you have any questions, a lot of times you can get support also by going to the O3DE Discord, which you'll be able to find a link as well in the video. Okay, now that everything's been pulled down, let's go ahead and make sure that we actually do have everything. So you can go into your O3DE folder here that's just been created. You'll see all of your files are in here. And what we can do is we can just make sure by doing a git LFS pull, just to make sure that we actually have everything. It'll check if everything's good. We're good to go. Now remember, we're working off of an actual fork here. So that means that there'll be the main repository, which is going to be getting updates, and then there'll be your actual repository, which may be out of sync. So one of the things you're going to want to do is you're going to actually set your remote for the upstream repository so that you can get your updates and rebases and things like that. So to do that, what you want to do is you want to actually do a remote add upstream. And your upstream address is going to be the actual original where you forked from. So it's github.com/O3DE/O3DE.git. And so once you add that, you can check to make sure that you've got it right by doing git remote v. You'll see that it knows that the origin here that you're working from is O3DE user, but your upstream is O3DE git. And what that'll allow you to do is you can actually stay in sync with the repository that's the source of truth, which in this case is the one that's O3DE. And you can do that by doing git fetch upstream. And this will go and check and see if there's any differences between them. You'll see here that we've got a few branches and things like that that we can work from as we go through. We go to O3DE, O3DE. You'll see that we actually have the different branches and things like that that are in here. But you'll also find that inside of yours, you have the same thing. So with that in mind, we've actually now have it locally, and we're going to be able to get ready to start building this and do something bigger. So now that we have all the binaries pulled down and we're showing some of the different branches, let's talk about that for a quick second. To give you a better understanding of what you should be working from, we've decided to use the Gitflow type of work stream. And so I'm going to pull that down so I'll give you a quick understanding of what we're doing here. And so if you look what we have here, we have a handful of branches, and this is the Gitflow that we're actually using. Now, to give you a better understanding of why we're using this type of a model, it's to allow developers to build inside of this and also to have stable releases. So you'll find out that if really what you want is the most stable release that's up to date, you're going to want to get that from main. And that's where everything starts. So from main, we have everything that has all the fixes, all the point releases, long-term support and things like that. Now from those, just so you understand how a lot of this works, the latest and greatest features is actually a branch off of that, which fits into develop. And all the features then are branched off of that where they're worked on, kind of like what we did here where we made a fork. And when the users actually, when the different developers make a fork, they'll be working on their feature branches. They'll build their features, and then they'll do a pull request to put them back up and develop. And then from develop, that will eventually become where they begin building a stabilization release branch, which then gets tested and tested and tested until it finally gets hardened to the point where it's a good point release, and then it gets merged back into main. So really depending if you want the main here where you're pulling all of the different releases that are current, and they are also kind of stabilized. That's what you'll want. If you want to get the latest bleeding, cutting edge things, you'll want to use the develop branch out of that. So the next thing we're going to do is we need to actually create a third-party folder. And this is where a lot of the dependencies will need to go. So what you'll want to do is you'll go and create a folder, and you may not want to create the third-party folder inside of your O3DE, but make it a separate one. So in this case, I'll create an O3DE-third-party. And we'll put that peered to O3DE. And so the next step we're going to take is we're going to go ahead and use CMake to begin building this. Now you can use the command line or you can use the GUI. In this case, I'll show you the GUI first so that you can better understand how to put this together. So we'll go ahead and load that up and we'll bring that into the view. And so we have CMake here. And what you're going to want to do is point to where the source code is. So that's the first thing it wants to know, which in this case is O3DE. Now it's going to want to know where to build the binaries. We're going to want to create a folder that's for our build because we're going to generate the solution files and things like that there. So what you're going to want to do is actually make a directory called build. And if you're on Windows, let's say we want to create one called Windows VS 2019. Okay? And we can see we have a blank folder. Now we're going to want to take this path and we're going to put that into where we're going to build our binary. So again, O3DE, and then build Windows VS 2019. Now once you've got that together, you can go ahead and configure. It's not going to pick up everything right away. We're doing this just so it starts getting the initial parts. You want to use the defaults for here. So in this case, you should already have had Visual Studio 2019 installed. You click on Finish. It will select the SDK, do a little configuration, and then it's going to fail out. The reason is because we need to actually configure where the third party is. So it's telling us we don't have a third party folder. It doesn't exist. We haven't specified. It's telling us we need the third party path. So what we'll do is we're going to create a new entry called live third party path. It is a path, and we want to point it to that folder we created earlier. So O3DE third party. Now once we have that, we can go ahead and configure again. So one of the things you might find with CMake, even though you put it in, it doesn't always take the value. You just have to do it again. It's just one of those things. So you go ahead and put it in again and hit configure. So what this is going to do is this is going to download the dependencies into your third-party folder. And those dependencies are what it needs to actually build the package. So as it's pulling these down, you'll see it'll download them, unpack them, get them put in place. And if we can go, we can actually take a look real quick. We can say O3DE third party. And you can see it's pulling down downloaded packages where we have these different zips that are, or in this case, tars, that are being pulled down. It'll decompress and put them in place. Once this is done, we'll be able to finish going through and configuring CMake and get this thing to begin building our Visual Studio files. Now, the cool thing about CMake is that even though in this case I'm showing you Windows, you can do the same thing for Xcode or the different environments because CMake can actually generate those to the native environment. Okay, now that the package is actually done pulling down all the dependencies and things like that, let's go ahead and also tell it to do one more piece. Now, we have the actual engine itself kind of configured and it knows how to build the files. But what we need to also tell it to do is to build a specific package of what we want to do. So you'll have a project, and you can tell it to do multiple projects, but you'll need a starting project to work from. So what you'll find is, now that we've done this, by the way, you'll see your VS 2019 has a bunch of build pieces in here. But you're going to need a project to work with, and you're going to want it to be able to work with that. There's one that comes with this by default, which is called automated testing. There's a few others that you can find on the repo that you'll be able to pull from. But we need to actually tell it that it should include that in the CMake build. So we'll tell it ly projects, and we're going to tell it that the value here is automated testing. so that it knows that it should at least build that. Make sure it's still here, like we ran into before, and you can click on configure. It'll quickly kind of burn through here. Make sure that we've got all the pieces that we need for the package and the dependencies, and we're good to go. So once that's done, you can actually click on generate. Generate will now create the Visual Studio files that we'll be able to pull up in Visual Studio 2019, and that'll allow us to build it. Now, if you remember, I did bring up that there's two ways of doing it. One of the ways you can do it is in the command line. The other way is with the GUI. It's really your choice of which way you want to do it. This is just kind of a much more illustrative way. So now that we have that part done, we can actually open up Visual Studio. Our files themselves are located here in our O3DE build VS 2019. So we can go ahead and open a project here. And we can tell it, let's go ahead and get that from O3DE, build, Windows, and you can see we have all these solution files. The one you want is O3DE solution. So you go ahead and open that up. And that'll load in all the pieces and everything you need to be able to build the source and to build the engine from the ground up. At this point, you're pretty much ready to go. You can see everything is here, all the elements. So what we do here is you can either go by debug or you can go by profile. In this case, I'm going to go ahead and tell it to go to select profile. And once this comes back, at this point, we can build. And so it'll be off to the races. This can take a little while depending on the number of processors and the memory and disk speeds you have. Expect to go get a coffee. It will take quite a little while. This is a very fully featured engine. It has a lot of elements, a lot of components to it. Once this is done, we'll actually be able to start it up and run it and be able to see what's going on. There are a few other things that you'll need to do, though, before you actually get it up and running. We're going to need to register the engine so that the engine actually knows where it's located, where it should run from. So understand that a lot of the way this works is this is a non-monolithic type of engine. So in other words, the engine itself lives in different folders where your project is located, and it can also be pulled apart by pieces. So with that in mind, that's the reason why you'll actually register your project, you'll register your engine, you'll register your gems, so that you may have them located in different places, but it knows how to find them, interact with them, and work with them. So once this is done building, you should be able to go off to the races, but again, we're going to wait for this to finish what it's doing. Okay, now that our build is actually completed, one of the things you'll want to do here is you're going to want to set a default project to begin from. So what we'll do is we'll go into Code and then Sandbox, and you can right-click on Editor here and set this as your default startup project. Because when you first start using this, you're going to be using the editor. Later on, when you start building games and things like that, you can set those as your default to be able to debug through. Now, even though we have this in here selected, we still need to actually register the engine because it doesn't know where to find itself. So within O3DE, there's actually a thing called scripts. And inside of here, there is a script that's O3DE. And when you run it, it actually has a lot of configuration pieces. So the first thing we need to do is we need to tell it where to actually find and to register this engine. So to register the engine, it's actually pretty easy. What you can do is just say O3DE, register this engine. Now, if it does this where it comes up and it says, a lot of people make this mistake where it says, you know, I can't register it because the path is this, or if there's an old one in there, you have to actually force it. There was a previous build that I had set before, so what we can do is we can just simply force it by just adding -F. Now it knows that this engine is registered, and it knows what it needs to do to actually be able to get started. So now that you actually have that registered, let's go ahead and start debugging with this. So you can have it here, it's already set for editor. Go ahead and F5 and let Windows start it up. You'll see that it begins bringing you into a projects folder. Within the projects folder, you can actually create a new project. Now here I've had a bunch in the past that I've previously had loaded, but we'll go ahead and create a new project. You'll find that your users folder is where a lot of the projects and templates are stored, and you have different gems that you configure. But in this case, we're just going to start with the default, and we're going to create a project. So now we have a new project, and for here you can actually build the project itself, which is what we'll do. So we'll do build project. Ready to build, say yes. Now this is doing it through the UI, but you'll want it put into your package as well so that it'll come up in Visual Studio. You can run CMake and specify this new project package so that it comes up in Visual Studio and you can actually debug through it. And what this will do, this will build all of the actual files within your project so that you can begin working with it. So let's take a moment and talk about how you can actually make changes to some of this. And so what we'll do in this case is we're going to take a look about building a feature branch on top of this and be able to have that push into our repository and then create a pull request to see if the maintainers and reviewers will allow it to be accepted into the top line repository. And all of the pieces that you need to know in regards to submitting code and features can all be found on the O3DE GitHub repository under community, and you can also work with each one of the SIGs around that. But with that in mind, so right now we know that we have a Git branch, and we can see these are all the different branches from the origin of what's on the remote. But we know our local that we're working out of is main. So what we'll start with here is we're going to actually begin to create a branch. So we'll git checkout, and the branch we'll just call it new feature. And so we have a new feature now, branch, so we can say git branch -a, and here we are sitting in new feature, and let's just say we wanted to create a new file called, new thing. So we'll create this little text file and we'll say this is a new feature, and we'll save it out. Now we have to push this back into our own repository, so we're going to git add, and then we will git commit, give it a message. This is a PR test message, or whatever. Oh, also you need to make sure you have your global configuration set. So in this case, user email, we'll just say is going to be set for O3DE test or user. All right, and so now we have that. That's actually been committed. It's in our repository at this point as a new branch. So the next thing we're going to want to do is we're actually going to want to push it. So in this case, we haven't set our origin on here, so what we need to do, git, it has no upstream branch, so we need to make sure we set that. And what this will do, this will make sure that it goes up into our repo, and we can verify this over here by taking a look. We've had recent pushes less than a minute ago. Now, if you'll notice, we see we have this new feature. Now, we can do a compare and pull request, and this is really important to understand how this fits in place. So what we'll do is we'll go ahead and click that, and what we're telling it is that we want to take this feature branch that we've done here, and we want this to actually be put into main from our new feature with a pull request And so we can take this, we can modify, leave comments, and when you're doing a pull request, you're going to want to make sure that you actually go through and have it tied to a ticket. Make sure that it's clear of what the feature is going to be doing, and you can create the pull request. And that will allow the maintainers to then take a look at it, have the reviewers go through it, and if they accept it, then it can be put into the O3DE repo, and from there, that's how you can continue moving forward. Once you're done with this feature branch, if you're not really going to do anything else with it, you can delete it, you can create a new feature branch, but it's important that as you're working in each one of these feature branches and you're working with them, that you always make sure that you always have your fetch upstream and that you're pulling back down. So when you're working with your code and you're doing different commits and changes to make sure you're in sync, you want to make sure that you're actually doing your fetch so that you actually are getting everything you need and you're doing the merges. And so that's how really you can do a lot of code changes and things like that and updates. Something to be aware of, though, is that whenever you're doing a pull request, you want to make sure you understand which branch you're actually trying to push back to. In this case, I was showing you that it was going back into main, but you would never actually push to main because main is something where only stable releases go, and that's handled by the maintainers in the SIG release. Then they'll make sure that when the code has actually gone through and they've done their regression testing on it, they've gone through stabilization, it would be merged up into main. Your code from your feature branches would always go into the development branch, which is where they would be. If you would try to send a pull request into main or into another area that you shouldn't be, then you'd find it would probably be declined.
In this video, Royal O'Brien provided us with developer's overview of the O3DE setup process. Stay tuned for future videos where we will discuss more O3DE related content.